In last tutorial, we skipped over the section about pseudocode, and this presentation is going to cover everything you need to know about pseudocode. This presentation runs in parallel with section 6 of your workbook. We'll cover what is pseudocode, why do we use it, who uses pseudocode, and we'll have examples throughout. So to explain what pseudocode is, I'll first review what an algorithm is. An algorithm is a procedure for performing a computation. You can think of an algorithm as a recipe. It has inputs, a set of steps to perform on those inputs, and finally, it produces outputs. And now for pseudocode. Pseudocode is a code-like way to describe an algorithm. We've already covered one way to describe algorithms, using flowcharts. Flowcharts are good for describing an algorithm at a very high level, but when there's many steps involved, it becomes tedious. Pseudocode is usually much faster to develop and can be more easily converted into code. I know from being a TA in ENS 233 that pseudocode is one topic that might bring back nightmares for some of you. And I think that because some TAs have their own opinion of what pseudocode should be, and they don't accept other forms of pseudocode. But it's important to understand that there's a spectrum of pseudocode. There's pseudocode that's much closer to English, and pseudocode that's much closer to code. Pseudocode that's closer to English is usually more easy to understand for a broad audience, while pseudocode that's very similar to code is easier to understand for developers and programmers such as yourself. We'll see examples of both types by doing the workbook example number 1. Our task is to write pseudocode to describe an algorithm to find the largest number in an array of integers. Before we look at how to write pseudocode, I'll describe the strategy that we'll take to solve this problem. We'll begin by taking the first element in the array and setting it as the current largest. After that, we'll go through all the remaining elements of the array, comparing to the current largest at each step. If an element in the array is larger than our current largest, we'll reset the largest to be that value. And finally, we'll return the largest value. First, let's look at a solution that's closer to English. As you can tell by the quotation marks around solution, this is the solution given in the workbook. They describe the first step as, start with the first element in the array and assume it is the current largest. Second step, loop over all elements from the second one to the last one. And as part of the second step, at each step of the loop, if the array element under analysis is greater than the current largest, update current largest with that element's value. And finally, return the current largest value. Are you still awake? Although the pseudocode is clear and describes the algorithm, it is not quick to develop, which is one of the main benefits of using pseudocode. So let's look at a solution that's closer to code and faster to develop. Here's the first step. Notice that we're allowed to use variables as part of pseudocode. The first step says the largest value is assigned the first element of values. And also another variable called index takes the value 1. When writing pseudocode, you don't want your pseudocode to be restricted to a specific programming language. And to avoid the confusion between assignment and comparing if two numbers are equal, we use an arrow to indicate a value being assigned. As a second step, we have while the index is less than length of values. Notice here that we're allowed to use relational operators. In the example, I'm using less than. As well, you can use repetition structures. In this example, I'm using a while. Now the body of the loop, if values at index is greater than largest, assign largest to be values at that index. And finally, return our variable largest. Compared to the solution that's closer to English, it's a much more compact description, and it's also very similar to real code. However, at the same time, it's not restricted to specific syntax, such as using semicolons at the end of all the lines. Although close to code, pseudocode should never be tied to a specific programming language. Having developed a solution that's very close to code, we can easily translate into C code. There is almost a one-to-one correspondence between pseudocode to the solution in this C code. However, notice that the C code requires an extra integer called n, which represents the length of the array. When we wrote the pseudocode, we were allowed to assume that we knew what the length of the array was. If you wrote pseudocode to include the length of the array as a separate variable, that would be acceptable as well. Comparing flowcharts to pseudocode. The main advantage of flowcharts is that it provides a visual representation that can be used to easily comprehend the algorithm. The main disadvantage for flowcharts is that they're harder to develop and maintain. The main disadvantage is that it can be hard to turn into code, and it's also harder to develop and maintain. Pseudocode, on the other hand, should be quick and easy to develop. It should also be relatively easy to convert into code. Another advantage is that pseudocode can be placed into your source files. When someone else looks at your code, it can be much easier for them to read the pseudocode versus the actual source code. A disadvantage, in contrast to flowcharts, is that you can't understand an algorithm by simply looking at the visual representation of pseudocode. So those are nice advantages of pseudocode. But when you can just directly write code, why should you use pseudocode? It is often much easier to develop and iteratively improve your design by working at the pseudocode level. Once you have a sufficiently refined solution, you can translate your pseudocode into C code. Your C code can then be compiled, and you can test your code to make sure that your algorithm works as you expect. If something doesn't work as you expect, you can return to the pseudocode development level. This process is called pseudocode-driven programming. I encourage you to use pseudocode-driven programming, or PDP, in particular when you're designing an algorithm that solves a complicated problem. In case you're wondering, does anybody actually use pseudocode? The answer is yes. Pseudocode can be an effective way of communicating algorithms. Here's a scientific paper I recently published, and if you scroll to the second page, you'll see the first of several algorithms being described using pseudocode. And now it's your turn. Pause the presentation and attempt pseudocode example number 2 in your workbook. Resume playing once you've finished. Here's a particular pseudocode solution for finding the largest of 3 numbers. Your answer will most likely be different, but as long as it adequately describes the algorithm and isn't restricted to a particular programming language, it's probably correct. And here's how my pseudocode gets translated into a function I call largest of 3, which takes 3 integers and returns an integer which is the largest of the 3. Now, please go ahead and try pseudocode example number 3, which uses pseudocode to describe the solution to a quadratic equation. Here's my solution. Notice that I'm using many variables and mathematic operations. It is completely acceptable to do that. Also note that I'm using a generic output statement which doesn't link me to a specific programming language. Here's what my particular solution looks like in C. Now that I've translated to C, I'm using language-specific functions such as printf to do the output and sqrt to calculate the square root. So to review, pseudocode takes many forms, and depending on the situation, you may use a pseudocode which is more close to English, or you may prefer to use pseudocode which is closer to real code. Remember that pseudocode can have variables and equations. It also uses indentation to support readability and translation into code. And although pseudocode can look like code, it shouldn't have any language-specific connections. For this course, I recommend you write pseudocode which is closer to code, or put another way, write pseudocode, not pseudo-English. And now try to answer this multiple choice question about pseudocode.